Load-bearing structural steel stud construction has been around for many years, but recently has been getting more use and is gaining in popularity. Stuart Olson has just completed 2 hotels and started a 3rd using this type of construction. With the problems associated with the wood frame construction in the lower mainland of British Columbia, many owners are opting for a product that will not rot, has no shrinkage or settlement, is non-combustible, and will allow them to build more floors than a wood frame design. This can all be achieved at considerably less cost than conventional formed concrete structures. A building constructed of load-bearing structural steel stud, properly designed, will be considerably cheaper to build than a typical concrete structure. Savings accrue in several areas. Minimal reinforcing is required. There is considerably less concrete in a steel deck assembly versus a conventional slab. In this particular system, there is approximately 40% less concrete than in a typical structural slab. Large floor slab areas can be placed with a very small crew. In the case of the Sheraton Hotel, 11,000 square feet of deck was placed, complete with walls ready for reinforcing steel in 3 days. Steel stud buildings are considerably lighter than conventional concrete structures and therefore require lighter foundations.
In this system here, the party walls are the load-bearing walls, and the deck is loaded all throughout this system. Areas on the roof that have heavier loading, you may have to substitute red iron or structural steel in certain locations to carry that point loading. That's one way of doing it, not quite as economical as just doubling up or tripling up the studs if they will do the same job, which has happened in several occasions here. Just might be that the loading needed some structural steel for it. One way of keeping the systems economical is to keep as much structural steel out of them as possible, because that adds cost, and it's not too hard to do because the steel studs will substitute for just about everything they need in the building. If you can avoid lintels, headers over windows, and doors as much as possible, it saves in the final cost of the building.
Other factors which contribute to the overall effectiveness: the ability to prefabricate major components of the structure either on or off-site. In the case of the Sheraton, all of the wall panels are prepared in a shop well in advance of them being required on site. A bundle of wall panels is placed on the slab and quickly put in place. A well-designed system will eliminate the need for temporary shoring under the deck. This allows tradesmen to commence work under the slab within 12 hours of it being poured. In a conventional forming system, there would be shoring or reshoring in place for up to 4 weeks, which would impair progress. The materials used in this system all end up as part of the final construction. There are no fly tables or loose forming lumber required in the deck assembly. This results in less preparation of false work, no forms to dismantle at the end of the job, and a lot less used material going to a landfill site. Load-bearing structural steel stud designs are ideal for repeat types of construction. The 3 Stuart Olson projects shown in this video are all hotels, where the rooms are a consistent size in a repeat configuration. These systems have been used in other applications, condominiums, and single-family dwellings. However, it's in a hotel application that the repeat economies are best achieved. The Sheraton Hotel shown here under construction is using a 3-inch metal deck system. The load-bearing walls are the suite demising walls, centered 12 foot 6 inches apart. This is near the maximum span for this type of deck. Any changes to this layout would require the introduction of structural steel to transfer loads. The Holiday Inns, on the other hand, used a different deck system called ComFloor. It has the capability of spanning longer distances, in this case over 27 feet. The exterior walls and the corridor walls were the load-bearing elements of the structure. This gives the designers the option of deleting any or all of the interior demising walls.
In this structure, the Holiday Inn Airport, we've used the ComFloor system, and the load-bearing walls, in this case, are the exterior wall and the corridor wall, with the deck bearing in this direction. And that gives us a lot of flexibility in the design layouts of the suites. In this case here, this was originally 2 units, but the owner wanted to put an upgraded suite in here, so the interior partitions were deleted and the room modified, and as a result you have this large open space in here. It gives a lot more flexibility in the design capabilities, and actually every interior partition for the length of this building could have been deleted if the need arose. You can put meeting rooms in, larger rooms, various things like that. One of the drawbacks might be is that there's thicker floor assembly in here, so there's a little more concrete, a little more height to the building, but you offset that with the flexibility in your room layouts.
A typical wall panel is built to engineered specifications complete with shop drawings indicating cross and lateral bracing and size and spacing of studs. Once the walls are stood up and braced, the deck is installed. It can be either welded or screwed down. We chose to screw the deck so as not to be hindered by rainy weather, which is not conducive to welding. As with conventional concrete construction, there's an engineer's inspection prior to pouring to ensure the deck is ready to take concrete and the reinforcing is installed properly. As pointed out earlier, the reinforcing requirements for this system is very nominal. In some cases, wire mesh would be all that is required. The concrete thickness for this slab is 2.5 inches on a 3-inch metal deck. The concrete pour goes very quickly, and the placers have no problem placing and finishing the 11,000 square feet in one day. Scaffolding will be required during the course of construction for the exterior finishes, so we install it earlier than usual. This has a twofold purpose. It gives a safe work platform at the perimeter of the building for the deck installers to complete the bulkhead installation, and it acts as a safety railing for the men working on the finished deck. Maintaining a safe, clean work site increases productivity. There's no lumber laying around from a conventional forming system cluttering up the job site. The final product of a structural steel stud building can be just as interesting and architecturally pleasing as any building. In the case of this Holiday Inn, even the dormers and towers at the roof were constructed of structural steel studs, with very little red iron in the design. Load-bearing structural steel stud construction is an economical, efficient, time and labor-saving method in all weather conditions, resulting in shorter schedule periods and in earlier openings. As with any type of construction, proper planning and input at the design stage is important in achieving all its benefits and avoiding the pitfalls. Having a knowledgeable contractor working in conjunction with the architectural and structural team will help ensure a successful project. At Stuart Olson, we have the experience and expertise to assist you in your construction needs, whether they be in steel stud construction or otherwise. We are a diverse general contractor and project manager in all types of commercial, residential, and light industrial construction. Whatever your construction needs, or if you have any questions and require further assistance, contact Stuart Olson Constructors.